In this video, I'm going to show you how to quickly calculate the duration of the bond using Excel. Now we have to have a coupon bond. Let's say we have a 10-year coupon bond of 3% coupon rate. So let's put down coupon rate over here of 3%. Instead of 3%, I want to put down decimal, which is 0.03. Now keep in mind that in calculations, we always use decimals as opposed to percentages to avoid mistakes. Now for the 10-year bond, I need a 10-year timeline. So I'm going to do it from 1 through 10. And then I need to find the market discount rates. Now to find market discount, we simply go to the website, Google, and then type in the yield curve. And as we can see, the very first link down here is the link to the US Treasury Department. On this website, we can see daily US Treasury rates. For our purpose, we just need the very first one. So we'll copy it over here. Now, anything less than 1 year is not used, so we get rid of those. So for 1 year to 3 year, we can copy over here using transpose. So I can turn this row vector into a column vector. Now the 5 year, I'm going to copy over to here, 5. 7 year, I'm going to copy over here, 7. And then 10 year, I'm going to copy over here, 10. And I get rid of everything else which is not used. As you can see, we have several blanks here to be filled. So we have the 4-year rate that's not available in the market, 6-year rate, 8 and 9-year rates that are not available from the market. Now there are a number of ways to fill these blanks. One easiest way is to do linear interpolation. Now 4-year is in exactly the middle between 3 and 5 years. So what I'm going to do is that I'm going to take 50% of the 3-year rate and 50% of the 5-year rate to get my 4-year rate. Similarly, I'm going to take 50% of the 5-year rate and then 50% of the 7-year rate to get my 6-year rate. Now for 8 and 9-year rates, I have to do 1/3, 2/3 split. So 8 is closer to 7 than to 10, so I will have 2/3 of 7, which is 67% of 7, and then 1/3 of 10, which is 33% of the 10-year rate. So 9-year rate is done in a symmetrical manner. So 9-year rate is closer to the 10-year rate than to the 7-year rate. So I'm going to do 2/3, 67% of the 10, and then 1/3, which is 33% of the 7. So now I have my market rates. Now keep in mind that this is in percent from the website. What we need is in decimals. As a result, I need to divide each and every rate by 100 to get the decimal. Now I have the first one, then I copy paste by double clicking the lower right corner. Now I have my discount rates in decimal. Now for future calculations, it is a lot easier that we turn these discount rates into discount factors. So discount factor is nothing more than $1 present value discounted at the discount rate. So it's $1 discounting, meaning dividing by 1 plus the discount rate to the power of time. So I have a discount factor of 99.83, and then I copy all the way down by double clicking. Now these discount factors are declining as they should, simply because $1 in the farther future, it was less today. Now, next I'm going to bring in cash flows of the bond. So the cash flows of the bond are nothing more than coupons and the principal. So the coupon will be the coupon rate of 3% times the principal. So here I have B1, but I need to hit F4 to anchor the address B1 so that when I copy paste, this address won't change. So I take B1 multiplied by my principal, which I assume to be $100. Therefore, I have a $3 coupon for every year. And then I copy paste by double clicking. Now for the last one, I need to add the principal back, which is $103. Now you can see I have the cash flows of the bond. Then I'm ready to calculate the price of the bond. So the price of the bond will be discounted cash flows summed all together. So the way to do that is to use Excel function sum product. This Excel function will multiply each cash flow by its corresponding discount factor and then sum them up. So I'm gonna just block the cash flow and then block the corresponding discount factors. So I have the price of the bond, which is 123.026. Now we have to find the yield of the bond. Now remember, MaCaulay duration is based upon the yield of the bond. So I have to find the yield of the bond. Now the yield of the bond is nothing more than the internal rate of return of the bond, which means the bond is expected to make this much return when everything else is held constant. I don't know the answer to this yield, so I'm gonna first randomly put down some number. So I'm just gonna say this is 1%. Later on, we're gonna solve for this yield. Now, if the yield of the bond is 1%, then we can actually find the discount factor using this 1% as the discount rate. So this is using yield. So it is $1 present value discounted at the yield. So again, it's $1 divided by 1 plus the yield, but the yield cannot change as I copy, therefore I have to use F4. And then to the power of time. And then I copy paste all the way down by double clicking. Now I have the discount factors using the yield. And then I'm going to use these discount factors to bring back the present values and then the price of the bond. So I'm going to do sum product again. All my cash flows discounted by corresponding discount factors. Now, as we can see that this present value does not match the market price, which means that our yield is incorrect. To solve for the yield, we use solver in Excel, which is under data. So what we need to do is to set this as the target cell. We want that to equal to the value of the price of the bond, which is 123.026 by changing this yield cell. Now hit solve. Here we can see that the present value that we compute using the yield is now the same as the price of the bond. And the resulting yield that we just solved for is 0.00618. Now the MaCaulay duration is based upon this yield. So we're going to compute the MaCaulay duration now. So the first step in calculating the MaCaulay duration is to compute the sum product of the cash flows and the times and the discount factors. So it is each cash flow multiplied by the corresponding time and then discounted by the corresponding discount factor. So it's sum product of the cash flows by corresponding times and then discounted by the corresponding discount factors. The second step is to take this result and then divide it by the price of the bond. So the MaCaulay duration for this bond is 8.92 years. In the next video, I will use a different method to compute MaCaulay duration. That method is a lot more efficient, so see you there.